about graphics, basics of graphics, or how to plot data, given data, how we are going to plot in Matlab. That is what we'll do. We'll see some demonstration like slides, or some slides which are like demonstrations of Matlab, and some slides where I will explain that. So I will explain, then the explanation will be available as a demonstration. That is what we'll do. As you know, plots can be of two types. In Matlab, plots can be of two types, or in general, we see two types of plot. One is a two-dimensional plot or 2D plot. Other is a three-dimensional plot or a 3D plot. Now let me start with basics of 2D plot. So basics of 2D plot. I'm not going to discuss about what is meant by plot. As you know, plot is, you will be given 2D plot. If it is a 2D plot, you will be given some data in X or along X. X is represented by the X axis. So some data will be given to you, with respect to which there will be other data or variables. So the first which is given to you is the variable. Then using that variable you get some answer, that is y. So for each x there will be a corresponding y. Then in the xy plane, for each x we find out a point. For each x corresponding point, for each x and y corresponding y, we find out a point in xy plane. So for each x there will be one point corresponding to each x and y pair. Then we join all those points, that gives us a plot. So that is a 2D plot. Now we can have one set of x, or we can have n number of sets of x. So if we have one set of x, then we will get one set of y, and we will get one curve or a one plot. If we have more than one set of x, then we can have more than one plot. Now all those plots can be in, can use the same xy axis, or we can have those plots on different xy axis, so different plots. So in one plot we can have many graphs, or we can have one plot for each graph. All these things we are going to see. Now suppose to me or to us, one thing is given, x is given. X is between 0 to 18, and it increments of x is by an amount of 2. So 0 colon 2 colon 18. That indicates x is equal to, within square bracket, 0 colon 2 colon 18. Then I am giving a semicolon, which means there will be no echoing of these values. So x will be 0 to 18, it will be 0, 2, 4, 6 up to 18. And then we say that y values are also given, 18 y values are given. These are the y values, 0.33, you can take any y value. These are 18 y values. So 9 y values. 0 in increments of 2 up to 18 means you are getting 9 x values. Correspondingly, they will get 9 y values. If we plot that, the plot will look something like what is given below in the plot. We will see that in the next slide. So how to plot that? Give the command plot, PLOT, all small letters or little letters, PLOT, within circular bracket x comma y. So x comes first, so that will be the x-axis or the horizontal axis. Y comes second, that will be the vertical axis. Then for the plot we can give a title to the plot. So that title is given here, laboratory experiment 1. So you have, which means that the person who is writing this program has done an experiment in his laboratory, the first experiment. So laboratory experiment 1, that is being plotted. Then for the x, you can give label for x. That will be x label, x label, x label, x label. Then give a name for that x label. The name should be within quote marks. So x label, always x label is a function. Whenever we have a function, after the argument of the function is always within circular brackets. So x label, then within circular brackets, time comma s within single quote. Or if when we are using strings, we always mention them within, or we keep them within single quotes. So within single quotes, it is time comma s. That indicates that the x-axis, x label is for x-axis, label for x-axis. So the x-axis represents time in second, time comma s. Similarly, y label is distance comma ft. So y label represents this distance covered in its time in feet. Ft is for feet. Then grid on. So if I write grid on, then grid lines will be on. So please remember this. Plot command should be preceded by the title and labels. So first you have to write plot. After plot you can give title, you can give label. They can come in any order. So you can write plot xy, then x label time s, y label time, y label distance ft, then title, then grid on. These things you can do, but plot has to be first. So unless there is plot, it will not understand what is x label, what is y label, what is title. Matlab will not understand. So let us see if we put it in form of the program. So when we put it in form of the program, when you have your Matlab command window or Matlab program script window, so write it in the script window, whatever I wrote in the previous slide, I am writing here it in the window. So if I am writing it in the window, then I will press F9, which is for running the command or executing the command. The moment I press F9, I will see the same curve that we saw in the previous slide. So here you can see that on the x-axis, it is between 0 and 18. Above you can see x is equal to 0 to 18. So x-axis is 0 to 18. Y is given from 0 to 18.17. We have declared y. So y is here from 0 to 20. Maximum is 20. 20 is above 18.17. So that adjusts the plot. That keeps the plot within this range. Then y-axis, it writes distance ft, that you can see. X-axis, below x-axis it is time s. On the side of y-axis it is distance ft, and above the plot is the title of the plot, which is laboratory experiment 1. So you can see that using Matlab, when I execute these codes, I get this plot. Now let us see some commands of 2D plots. Plot is, it creates the xy plot. Command is plot x comma y. Title is adds the title to the plot at the top of the graph or at the top of the plot. X label is adds x label, which is horizontal, it is just below the x-axis. Y label is, it adds y label vertically along the y-axis, just beside the y-axis. Grid is, it creates or removes grids in the plot. So if you write only grid, it will switch on by default, it will switch on grid. So grids will be there. If you don't write grid, there will be no grid. Similarly, you can write grid on, grids will be there. Or you can write grid off. If you do not want grids, then grids will not be there. Then pause. Pause means the program execution will be paused. So at that point, the program execution will be paused. Figure. Figure means if we want to have more than one figure, then you can give this. Figure, within figure, after figure you can give 1 within bracket, within circular bracket you can put 1, 2, 3, that will be represents the figure number. Or you do not, if you do not give anything, it will automatically take the figure numbers. Automatically it will keep on adding figures. So without an input parameter, that opens new windows of figures numbered consecutively one up from the current window. Hold means keeps the plot on hold. We'll see its utility, which means if you want to have many plots in one figure, there we use hold. Hold means the figure will be hold. So figure will be kept on hold, then you can keep on adding plots onto it. When you say hold off, then the figure will be no more on hold. So next plot will be in a new figure. This is about something about the general commands used in 2D plots. So now let us see some of these commands, example of some of these commands. For example, if the current figure window is named figure 2, it will be figure 2. Now let us draw some figures. Okay. So this is a program, Matlab program, figure 1. So you can see figure 1, then plot xy, figure 2, plot xy, plot yx. So in this case, first is xy, first case figure 1, for figure 1, plot xy. So the first argument is x, second argument is y. So horizontal axis will be x, vertical axis will be the components in y, or the elements of y will be in vertical axis, elements of x will be in horizontal axis. For figure 2, elements of y will be in horizontal axis, elements of x will be in vertical axis, because y appears first, x appears second. Now you can see that since we have written figure 1 and figure 2, you can see two figures here. On the right hand side, when we execute this, you can see there are two figures. So first one is for the first xy, second one is for the yx plot. So in the xy plot, it is from 0 to 18, x is from 0 to 18. In the yx plot, x is from, or horizontal axis is from 0 to 20. Okay. So let us see something more about this. Plot xy, then put hold on. First we write plot xy, then hold on, then plot yx. If I do that, now you know x range is from 0 to 18, y range is lowest is 0 and upper limit is 18.7 something. So it will be upper range, we can take 20. So in both the cases, the maximum range is up to 20. Since we have put hold on, both axes will be from 0 to 20. So it will be lower axis is from 0 to 20, or horizontal axis is from 0 to 20, vertical axis is from 0 to 20. Both plots are appearing on the same plot. On the same figure, we are getting both the plots. One is in blue, other is in red. Right? And blue is for the first plot, plot xy, red is for the plot yx, and both are appearing on the same figure. So this is the beauty of hold on. Then if you put hold off, this figure will remain. Then the next figure, next plot command will be executed. When you write the next plot command, that plot will come up. But this figure will not be hampered with, or this will not be tampered. This will remain as it is. Now let us see how to use lines, color different lines. When we are drawing the plot, you can draw it using different lines, different colors, different marker styles or marking styles. Now before that, let me tell you what is the CLF command. As you know, we have discussed about CLC command. CLC command clears the command window. Similarly, CLF command clears the figure. If there is a figure, the moment you give CLF command, that figure will be cleared. So to close an active figure window, always you can use the close command, and to close all open figure windows, you can use close all command. So that is what you can do. Two things. One is clearing the figure, other is clearing the window, figure window or figure windows, all windows. So close all, closes all figure windows, closes the figure window, whereas CLF clears the figure. Now different line types. You can have a solid line, you can have dotted line, you can have dashed dot line, you can have dashed line. So these are the symbols for those things. So for solid line, indicator is only a single dash, dotted line is the colon, dash dot line is a dash, then dot, and dashed line is double dash. How to use that we will see later. Similarly, different types of points. So if I don't want a continuous line, but we want only data points, so different types of data points, whether it is point or a circle or X mark, plus mark, star mark, square mark, diamond mark, all these things are given here till hexagonal mark. Then what will the color of your point or color of your line? We can have 8 types of color: blue, green, red, cyan, magenta, yellow, black, and white. So these colors are: blue is B, green is G, red is A, cyan is C, magenta is M, yellow is Y, black is K. Remember this, black is K, not B. B is always for blue, black is K, and white is W. So these are the indicators, different indicators for line type, point type, and color type. Now let us see what happens here. We have already defined what is X and Y in the first slide. So for those X and Y, let us give the first command: plot X comma Y comma within quote mark. Remember here it is within quote, double quote mark, dash dash. This indicates that this will be a line which is a dashed line. So if I draw that, if I execute that, so you can see that the same line that we are drawing earlier, it was a continuous line, now it is a dashed line, double dashed line. Similarly, plot XYO, it will be zeros. Instead of double dash, it will be zeros. So you can see that it is zeros. At all points we have got zeros. Similarly, plot XYK, star K. So it will be star. It will be stars, and K means it is color is black. Now you can see the first two plots are blue color because by default it is blue. But if you want it black, then write K. So star K. So that is star marks in black color. So you can see all these three plots using different types of line or different types of marking. Now let us see how to scale the axis and annotate the plot. Right, here there is an example. Example is axis or axis V. When you say axis, the axis function is used without any input. It freezes the axis at the current configuration. Executing the function a second time returns a axis control to Matlab. So that is what happens using axis command. Axis V can be X or Y. So that way you can have command control over X and Y. Axis equal, it forms or forces or the scaling of X and Y to be the same. So maximum value and minimum value of X and Y axis will be same. Legend is within the plot, you can put some legends. Text is within the plot, you can put some text. And G-text is similar to text, and the box is placed at a location which is determined interactively by the user, by clicking in the figure window. So within the figure window, click at a place where you want to put. So then G-text, there you can write the string. Here is an example. Axis X min, X max, comma Y min, comma Y max. So that defines the limit from X and Y axis. For example, axis within round bracket, then we are putting the x max and y max within square bracket, minus 2 comma 3. So x minimum value is minus 2, x maximum value is 3, then 0, y minimum value is 0, 10, y maximum value is 10. So this is fixing x axis from minus 2 to 3 and y axis from 0 to 10. Let us write the program and see it in Matlab. If I write the program in Matlab, how this is being executed. Now, that is what we have written here. You can see the x-axis now is from, we have given x minimum is equal to 0, x maximum is equal to 15. So you can see here 0 x-axis is from 0 to 15. Lowest value is 0, upper value is 15 in the x-axis. Similarly, y value, we have given y minimum is equal to 0, y maximum is equal to 20. So that you can see 0 and 20 in the y minimum and y maximum. So that we have defined, but after plot we have used them. So after that we have said plot xy, after this axis x min, x max, y min, y max. So that gives the plot. Now let me see what happens if I make a slight change to that. Now let us write v is equal to 1, 10, 1, 18, which means if I write this way, v is equal to 1, 10, 1, 18 and use that in the axis command, then 1, 10 is for x-axis and 1, 18 is for y-axis. So instead of defining x min, y min, x max, y max, you can straight write v is equal to this or any vector. Write a vector a, b, c, d, anything you want. V, y, not y, because we are plotting x, y. V, w, z, anything you can write. So v is equal to 1, 10, 1, 18. Those are the values. So if I write that, my axes are fixed accordingly. So here you can see that x is not 0, x is 1. Okay. Then axis equal, you can see axis equal, plot xy, hold on, plot yx, hold off, which means plot xy, then hold on means the next plot will be on the same figure. So next plot is plot yx. So plotting is over, then I would say plot off or hold off. So after the hold is off, then we can put legend. Legend to plot, right? You can see on the right hand side, there is the plot. We have two plots. One is blue color, one is red color. Now what does the blue represent? What does the red represent? Therefore we have to give a legend. So if I give a legend, that will show a blue line for the blue color. So blue color is for string 1, a red line is for string 2. So those two lines you can see. So that is what is the string. That is what is the legend. Then text, we are writing text at the point 10, 10. You can see the axis, on the axis exactly at the 10, 10 point. For x-axis you see 10, for y-axis you see 10. So where those two meet, so that is the 10, 10 point on the plot on the 2D plane. At that plane it is writing string. So 10, 10, comma within quote mark string. So it is writing string. Now some of the special functions. Suppose we are using engineering notations or science notations. Usually in science and engineering you require science notations or engineering notations. Those notations comes from Greek letters. So if you want to use Greek letters in text instead of ABCD, you want to alpha, beta, gamma, etc. Then what you can do is add a black slash before the name of the letter. So for example, Y label within bracket, quote mark, start quote mark, then backslash alpha, then backslash beta, then backslash gamma, quote mark ends. So this will create the plot title. Title of the plot will be alpha, beta, gamma. If you want to use a superscript, use a caret. So X label, in the X label we are going to use a superscript F square. So X label, then within bracket put quote marks. Whenever we are using strings, you should put the strings within quote marks. So I will not repeat this put quote marks anymore. So whenever we are using strings are always within quote marks. So x, then caret 2, that will take it to square, x square. Then slash leq, lower than and equal to or less than equal to, slash leq means less than l equal to. So it will be x square, then less than equal to sign, or and then slash geq greater than equal to, then slash pi. Pi is for Greek letter pi. So example shows here. X square less than equal to 0, less than equal to or greater than equal to pi. So x square is less than equal to or greater than equal to pi. So this is what is the label in the x-axis. Similarly for superscript, for subscript, this is for subscript, x square is superscript. Now go to subscript. For subscript use underscore. For superscript use caret or hat. For subscript use underscore. So title x underscore 5. Now we can see example is x sub 5. For a group of characters, you can use superscript or subscript as a group. Then enclose within curly braces. Everything, the characters, if it is a group of characters, enclose them within curly braces. For example, title k to the power minus 1. So how it will appear? K, then caret or hat, then within curly braces write minus 1. So it will be k to the power minus 1. Now for a title with more than one line of text, you can write title, then within bracket put curly bracket, within curly bracket put first line of text, semicolon, separated by semicolon, second line of text, separated by semicolon, third line of text. So that way you can keep on adding the different lines of text. Now let us see whether this happens or not in Matlab when you write the program. Now you can see here we have used alpha, beta, gamma in the x-axis. In the y-axis we have used x square less than equal to or greater than equal to pi. So using this command we have got this. Then using this command title, first line of the text, semicolon, second line of the text, that gives me first line of the text in the first line, second line of the text in the second line. It is like a row. These lines are comma separated, semicolon separated, means first row, second row. This is the first row of string, second row of string. That is what is happening here. Now you can have subplots also. Within one plot you can have more than one plot. Within a main plot there can be many subplots. So subplot command, this subdivides the figure window within one figure. It divides it into m cross n matrix. M cross n matrix means m number of rows, n number of columns matrix. So m cross n matrix. So the command will be subplot m comma n comma p. Now suppose we have a 2 cross 2 matrix. So this will be subplot 2 comma p. Now what is p? P is equal to 1 means 1 means m is equal to 1, n is equal to 1. So that is the 1 point. Then m is equal to 1, n is equal to 2, that is p2. So this will be always from left to right. P is equal to 1, 2, 3, 4 plot number or figure number within the main figure. Now this following example shows you the plot of x, sin x, and sin x for different frequencies. So plot subplot, 2 subplots are given. X sin x, one is x sin x, other is x sin 2x. Now let us see what happens if I write it in Matlab. Now you can see that the same program I am writing here. Subplot, first is subplot 2 1 1, which means it is a 2 cross 1 matrix which means 2 rows, 1 column. So it will be within 1 column, and there are 2 plots. So 2, 1, 1 is the first plot. So subplot 2, 1, 1, that says that the first plot. First plot is for plot of x versus sin x, and the second one is for subplot 2, 1, 2. That is the second plot. So 2 is plot number 2. 2, 1 is in the second row, first one, first plot. So that will be 2. So plot x sin 2x. That is what is being done here. So you have sin x and sin 2x. You can see that the top one is sin x, the other one is sin 2x. Okay. Now logarithmic plots. So we have discussed how to write programs for logarithmic plots when we discussed the plotting initially. Now suppose we want to draw some logarithmic plots. X is equal to 0, colon 0.5, colon 50. So 0 to 50, x varies from 0 to 50 in increments of 0.5. Right? So which means about 100 or 101 numbers of x values are there. So x1 to x101. Y is equal to 5 star x dot square. So it will be increasing, squaring the x values. So dot, therefore we are using here dot create to x dot create to, which means element by element square of x. Now how we want to draw 4 plots. So that is why it is a 2 cross 2 plot. Subplot 2, 2, 1. So that is the first subplot, first corner. So 1, 1 corner. Plot xy, title is polynomial, unlinear to bilinear. Y label is y, and grid is on. So grid is on. Then subplot 2, 2, 2, which is 2, 2 is in the first row, and it is the second element, first row, second element. So that is the second element is semilog of xy. So semilog xy, title same polynomial, polynomial log slash linear. So one side y-axis is semilog, y-axis is linear, x-axis is semilog. Then third one is subplot 2, 2, 3. So it is a 2 cross 2, which means now we are going to the third one, which is the second row, first column. In the second row, first column, which is the third plot, second row, first column. Semilog, it is semilog y. Y is in the semilog format. Previous one was semilog x. X was in the semilog format. So here it is y is in semilog format, x is in linear format. Last one is log, which will be subplot 2 to 4. Now 2, 2 is there will be 4 plots. Now the fourth plot is the last plot, which is the lower bottom right hand corner. So this is how you will write logarithmic plots. Now let me draw these plots in Matlab. So this shows you the same thing in Matlab. The same program is written in Matlab here. This is directly from Matlab screen. So after writing the program in Matlab, we are taking that and we are taking a screenshot of the program executed in Matlab. Okay. So we can see all those plots here. Then this is about line plots or line graphs. Then there are other graphs like bar graphs, pie charts. These are also available in Matlab. So bar means it is a bar graph. Bar H means it is a horizontal bar. Only bar means it is a vertical bar. Right? It is a vector and vertical bar. This is a horizontal bar. Bar H is horizontal bar. Bar 3 is 3D vertical bar. Bar 3H is 3D horizontal bar. Pi is a pie chart. Pi 3 is a 3D pie chart. Hist is a histogram chart. And so we'll see some of the examples here. First example is figure 3. We have already seen 2 figures. So here it is third figure. Figure 3 means figure number 3. Figure 3, x is equal to 1 to 10, increments of 2, bar chart, bar x. So you can see the top right one is the x of figure 3. So that is the figure 3. You can see all the bars are vertically upward. Then figure 4, same x is equal to 1 to 10, bar 3x, bar 3x, which is the right bottom. That shows you the bar graphs, which are 3D bar graphs, 3D bars, vertical bars. Then you can see figure 6, figure 5, figure 4, after that figure 5. Figure 5 is a pie chart, it is a 2D pie chart, same, x is equal to 1 to 10, increments of 2, the pie chart of x is equal to 1 to 10. You can see the pie chart there. Then figure 6 is pi 3, so 3D pie chart is the lower left corner of our chart. So these are the 4 charts that you can see. Same thing we can see here. This one also shows the same one using subplots. Same thing, bar graphs and pie charts using subplots. So clear CLC, everything we have cleared. Clear screen has been cleared. X is defined here, Y is defined here, and then we are defining subplot 2 to 1. 2 to 1 means it is a 2 cross 2 plot. So there will be 4 plots. 2 to 1. 1 is the first element. Then 2 will be the second element in the first row, second element. Then 2 to 3 is the second row, first element. 2 to 4 is the second row, second element. And first row, first element is a bar chart, which is vertical bar. First row, second element is a Y bar chart, which is for Y. Similarly, for subplot bar 3, Y is a 3D bar chart for the Y, and pi x is a pie chart for the x. Same thing I have written here in Matlab and run it. This is a snapshot of what is written in Matlab. Same program is written in Matlab and it is executed in Matlab. You can see the same plots are executed here. The previous one I showed you example from book. This is exactly from Matlab, just a snapshot from Matlab program. Okay. Now let us look at XY graphs with 2 axes. Sometimes you require 2 Y axes. So when you require 2 Y axes, that I'll tell you. Now you see there are 2 plots you can see. The first plot, you can see in the first plot there are 2 graphs. In the first figure there are 2 plots. One plot is a straight line, other plot is gradually increasing, exponentially increasing. One is a straight line, other is exponentially increasing. The problem is that does not convey you the correct information. The reason is the portion that you see as a straight line is in fact not a straight line, it is a sine curve. But since the other part is increasing exponentially, so the value of the other part is very large compared to the value of the sine. Sine value is less than 1, within 1. So it is much less than 100, 10, everything. So therefore, compared to 10, it will be like appearing as if it is 1 or 0. It is 0. So that you get a straight line at 0. So in those conditions, Y values are different. 2 plots are there with different Y values. In one case, Y value is varies from 0 or minus 100 or minus 10 to plus 10 or minus 100 to 100. In other case, it varies from minus 1 to 1 or 0 to 1 or plus 1 to minus 1. So in those 2 cases, you require 2 axes. So this is the scales of axes are different. If you have 2 different axis scales, then use more than 1 axis, 2 axis you have to use. One scale for both functions y and y2 does not convey you proper information. So you have to use different scales, y scales for different functions, y and y1 and y2. y1 is on the left, y2 is on the right. Now that is, the program is like this: x is equal to 0 to pi, 0 to 2 pi in increments of pi by 20. And y1 is equal to sine x, y2 is equal to exponential x. Now we have two plots, so there will be two subplots. Let us write two subplots here. Subplot 2 to 1 is plot x y y1 and x y2. So that in one plot, figure, you will have both these y1 and y2 for one axis, y1 y axis. The y axis which is dominating, that will be taking precedence here. The title is single y axis scale. Then second subplot is subplot 2 1 2. It is a 2 cross 2 plot, so we will have only two elements. Plot y x y1 x y1 x y2. So we have two plots, and y plot y means two y axis. So two plots on the same figure with two axes. So both axes are scaled accordingly. X label is angle. Now let us see whether this happens, whether this is correct or not in Matlab. The snapshot of Matlab. This is from book. Now this one is the snapshot from Matlab program. I have asked one of our students to write Matlab programs and share me these snapshots. So you can see on these snapshots now, the first one shows you, the first one does not give you any information about the sine plot, whereas the second information clearly shows you the sine plot for which the axis is on the left hand side, and the exp plot, exponential plot, for which the y axis is on the right hand side. Okay. And then you can see an example of CLF. So that plot is clear. Then x is equal to pi, same plot. You can use semilog here. We are using semilog here. You can use log here, semilog y, semilog x. Using those plots, we are again plotting the plots. So if linear plots, it is invisible, you can use semilog plots. Both of them are visible in the top as well as in the bottom. Okay. This is the repetition of the previous one. Only thing is, it is a snapshot of from a real Matlab window. Now the fplot function. Fplot function actually plots without defining x and y a priori. So beforehand you are not required to define x and y. Straight away you can use the fplot function. For example, fplot sin x, comma, and range is minus 2 pi to 2 pi. So that will create a plot of x versus sin x for x values from minus 2 pi to 2 pi, minus 2 pi to plus 2 pi. First argument is always y value in the string which contains the function. Second argument is an array of x values. Now let us see whether we can draw this or not in Matlab. Now you can see this Matlab. Now there you can see there is a warning. What is this warning? Why you use this warning? Warning comes, and warning writes, a plot will not accept characters. So that is the main thing. So you cannot use character sectors here. Okay, or strings inputs in a figure. Okay. In future release of Matlab, this will not be accepted, but present release it is accepting. Now you can see that the curve is very smooth. If you write a sine for sine curve, you write define x, what is x, then what is y as sine x, then you plot that. That will not be so smooth as in this case. So if a function is available, inbuilt function is available, or if you have defined a function already, then always try to use the plot instead of normal plot. Okay. Now this ends our discussion on 2D line plots. We'll come to the 3D line plots now. So sometimes you require to draw 3D line plots. Now let me show you an example here. Clear CLC, which is clear everything. then CLC is clear the command window. Then X is defined from 0 to 1000 in increments of 10 pi. Y is equal to cosine X, Z is equal to sin X. Plot 3 means plot a 3D plot of X, Y, Z. This will create a three-dimensional line plot. Actually, this is a spring. You are seeing a spring or a spiral. Grid is on. Now, since we are giving a grid, so grid is on. X label is angle. Y label you can write cos X. Z label you can write sin X. And title is spring, a spring. So now let us do this in Matlab. This is the example from book in the Matlab. Okay, next. In the Matlab you can see that if I do that, I am getting this. So we can see the Matlab snapshot here. Okay. So now editing plots from the menu bar. What you have to do is, once the plot is done, once you have drawn the plot or figure has been drawn, then in the figure you will be able to edit it. So select edit in the figure. So you go to the edit in the figure window. In the window top you will find edit. So click that. Then you can edit the properties. If you want axis properties, write axis properties, or from the property editor of axis. Other properties also are there. Data aspect ratio mode. So C for mode to manual. Set this to manual and see the manual or help on editing this. Everything you can do using the editing here. Just let me show you one example of 3D sphere. So if you write sphere grid on, you will get this. Then grids you can edit. Everything you can edit. Just go there, right click on it, and you can keep on editing this. Now once the plotting is done or figure is ready, then you have to save that figure. How you can go save the figure? You can use the save as command. So in the file, if you go to the file, in the top corner left, there will be icon file. Go to that file, click on the file, then you will get a drop down menu. From the drop down menu, choose save as. So use the save as from that menu option. In the figure window, there will be many choices. Use the extension .fi to save the figure in Matlab specific format. Other formats are also available like JPEG, so that will be .jpg, enhanced meta file .emf, EPS, extended PS, so that is also available. So many other figures are available, options are available. So choose that and give a name to your figure and store it, save it. So it will be saved with that extension. For example, let me show you one example. This is, we have done the figure of the spring. So now you can see the figure window. This is figure 2. There you can see in the top left corner file, near that is edit. So if you want to edit, you can edit. If you want to view it in different manners, you can use. Insert anything you want to insert into the figure, you can use that. Different tools are there. So everything you can do. Now in the file, if I have clicked the file menu. So once I click file, it shows the drop down menu. In the drop down menu, from the top you can see the fifth one is save as. So click on the save as. The moment you click save as, you will go to another window. Next window will appear. So in the next window, it will show you the file name. Below bottom you can see the file name. So write the file name, then save the figure as type. What is the type? Below one is the type. So you can just save it as figure, bitmap, BMP, or JPEG, EPS, anything, extended meta file. So everything that you have to choose. Then enter, click, or enter, enter key, press the enter key. That will be saved in the name that you have given as the type. So with this, if you have any queries, please ask me. Otherwise, we'll stop here. Thank you for being present today.
Sir,
Hmm. Hello.
ଆଜ୍ଞା ସାର୍ ଯୋଉଟା ସେମିଲକ୍ ଯୋଉଟା ୟୁଜ୍ କରୁଛୁ ସେଟା ମାନେ କୋଉଠି କୋଉଠି ଆମେ ୟୁଜ୍ କରିପାରିବା?
Semilog ତମର amplifier